Hello class. Today I am at Great America, as you know. So today the lesson you'll get is on the volume of pyramids and cones. It's chapter 12, section 5. Remember to turn in your homework today if it hasn't been collected yet. Also, you'll have homework assignment tonight, which will be due tomorrow on Wednesday. And then on Wednesday, tomorrow, we will go over section 6 on surface area and volume of spheres. And then on Thursday we'll review, and the test will be on Friday. So just so you have a little outline of the week ahead, as I always like to do at the beginning of the class period. So let me move this out of the way. Oop, didn't grab it. There we go. And so today it's pretty straightforward. We're going to find the volume of a pyramid, volume of cones, and then put some of those shapes together to get the volume overall. Volume of a pyramid. Volume equals 1/3 area of the base times the height. So that's the formula. As we learned yesterday, volume of a prism is area of the base times the height. So for a pyramid, it's just 1/3 area of the base times the height. The only change is you're really just multiplying by 1/3. So if you have two solids, a pyramid and a prism together, and they have the same base shape, and their height is the same, the pyramid would be just 1/3 the volume of that of the prism. I think it would have more surface area, but we're not really worried about surface area right now. And so for a cone, sorry about that. And so for a cone, the volume is 1/3 area of the base times the height still, except the base of a cone is a circle. So instead of doing big B for area of the base, we're going to do this pi r squared here for the area of a circle, which is still the area of the base because the base is the circle. So the two formulas you need to know are volume of a pyramid, which is 1/3 area of the base times the height, and volume of a cone, which is 1/3 pi r squared h. So then what we are going to do is we have 5 problems today. We'll go through those problems, and that would be our lesson. So the first one is at the bottom of this page. And what we've got is we need to find the volume of this pyramid. It has a regular base. So the first thing I would do is just write down the volume formula. Volume equals 1/3 area of the base times the height, because it's a pyramid. So now off to the side, I'm going to figure out what the area of the base is. So the first thing you have to do beyond, to help you figure out the area of the base is figure out what shape the base is. We've got 1, 2, 3, 4, 5, 6 sides. There are 6 sides. The other thing it told us is that it's a regular base. So the bottom is a regular hexagon. So the base is a regular hexagon. Now, area of a regular hexagon, we could use 1/2 the apothem times the perimeter. The perimeter would be easy to find, but the apothem would be a little more difficult. So one thing we could do instead of 1/2 the apothem times the perimeter is treat this base as 6 equilateral triangles. And we've talked about this before. So I'm going to bring up a hexagon here, make it a little bit bigger maybe. And so this is what the base looks like. So if you're looking at just the, let's say, bottom of this pyramid, it would look just like this hexagon. So what we're going to do is we're going to draw in, hopefully I can hit these pretty clear here. We'll draw in the diagonals to the opposite vertices from each diagonal. I'll fix that second one in a second. And what I'm saying, and what we've talked about previously, but I'm going to repeat it, is the fact that this hexagon is broken up into 6 equilateral triangles where all the sides are the same. Every hexagon, regular hexagon, can be broken up into 6 equilateral triangles. And so if you look here, it said 2 centimeters. So all these lengths are 2 centimeters. So instead of using 1/2 the apothem times the perimeter, which we could do. Oh, I could just put that down there like that. I'll scroll that down. What we can do is treat this like 6 equilateral triangles. And the area of an equilateral triangle is 1/4 s squared times the square root of 3. So what we get then is 6 times 1/4 times s, which is 2, squared times the square root of 3. 6 times 1/4 times 4 times the square root of 3. Now if you notice, 4 times 1/4 is 1, so what we get is 6 times the square root of 3. But we've been okay with having approximate answers. So what I'm going to do is take the calculator here, clear out what I did in a different class. Might have been your class. No, it was a different class. 6 times the square root of 3. Plug it in the calculator. And you find out that 6 times the square root of 3 is approximately 10.39, and we got centimeters squared because it is an area. It became squared if you're following the units because 2 was squared, and so this was 4 centimeters squared, and so it all became square centimeters through that step right there. So now we're going to go back and plug that in. So we have 1/3 the area of the base, which is 10.39, and then times the height. Now the picture on the height here is this is an oblique pyramid. And as I mentioned yesterday, using the Slinky, if it's oblique, it doesn't really matter. The height is still the height layered on top of each other. So the volume doesn't change, even if it's a right or an oblique cylinder, pyramid, prism, or cone. So here, although it's an oblique pyramid, the height is still what it is stacked on top of each other. So this being a right angle here formed, our height is 5 centimeters. So we just put 5 in for the height. And so what we're going to do now is take the calculator, standing in the way, there it is, clear that out, although that was our last answer, so we can hit second answer. Well, actually first, let's put 1 divided by 3 for 1/3 times second answer times 5. And this, because our last answer was the 10.39, will get us the answer we want for this problem. So our volume, this will be what I box, is going to be 17.32. And don't forget, units are cubed on volume, so it's cubic centimeters. And that is how you do this problem. I'm going to scroll up just a little bit. You can see the whole problem. Let's take it in for a second. If you have questions on any of these notes, I will be here before school tomorrow. We could also talk about it during class tomorrow, or you can come after class tomorrow, that all being Wednesday. Truthfully, if you couldn't make it on Wednesday, you could come in on Thursday, because we could talk about it there, because your test is not until Friday. So Friday's the big day. But hopefully you kind of followed all this. This is probably one of the harder problems we'll do today. So we're moving on now. And we're going to do example 2. And there's a A and a B part here, so we'll just put a line and do A first. Now the shape here is a cone. So we're finding the volume of each cone. Actually, both of these are cones. So the volume equals 1/3 area of the base. Because a cone has a circular base, the area of the base is pi r squared, like a circle, times the height. So what we get here is 1/3 pi. The radius, if you look, is given to us as 6.7. We'll square that and then multiply by the height, which is 10.2. Now understand, when we did surface area, we had to find the slant height. I'll use the big green marker here. This is slant height right here. But since we are doing volume, the up and down, which is perpendicular to the radius, that is the height, and that's the number we want for height. And of course, I've already colored this red, but I'm going to double color it red. This was your radius. So although this in green was your slant height L, we did not need it for volume. If we were finding surface area, the slant height wouldn't matter. So now what I'm going to do is, I think actually we can just type this all in our calculator. So I'll clear it out. I'll show you how to type it in your calculator. If you have this calculator or any really calculator that types as you go, you can go 1 divided by 3, then multiply by pi times the radius, which is 6.7 squared, times 10.2. This text wraps a little bit. That's okay. We'll come over here, drag it over, and that's what we did on the calculator. And so the volume is approximately 479.49, and the units was meters, so it's going to be volume, so it's cubic meters. So let me double check. Yep, that's the answer I've had in the past. It's always good to check when I'm recording this so I don't make some mistake because no one's catching them. It's just me in the room right now. All right, now we're going to do an oblique cone. Actually, let me go just scroll up a little bit in case you were looking at that. So now we're going to do this oblique cone below, and it says circular as the middle thing because the base is a circle. So we're going to do an oblique circular cone. And the thing about an oblique cone compared to a right cone is not much different. The one thing about a right cone is the height is measured right in the middle of the circle, straight up to the vertex. But in an oblique cone, the height is going to be measured maybe outside a little bit. Whatever we take from this vertex here, it goes straight down and it's perpendicular. So that's the height of 7. So that measurement right there is really the 7 right here coming out. So it's measured perpendicular to the radius, maybe not at the center of the circle, but perpendicular nonetheless. So we're going to use the same formula. Volume equals 1/3 pi r squared h. So we have 1/3 pi times the radius, which is 3.1, squared times the height, 7. And again, I would just type all this in my calculator right now. Saves time a little bit. 1/3 times pi times 3.1 squared times 7. So volume is approximately 70.44 inches cubed. Again, look over at the units there. We had inches cubed, or inches as the regular units, so it's inches cubed. So those are 3 problems done. We only have 2 to go today. Shouldn't be too long of lesson. Just looking at some things here before we move on. So let me actually go full screen while I look at some of my notes just quickly so you can see both problems we just did, parts of example 2. And so you can see that. Looking in my book, good answers. All right. Next problem is like a problem we did, I'm going to say today, but it's really yesterday for you guys. And so close that. Next problem, where you have to find a missing measurement. And in this problem, we're given a cone, and we need to solve for that x. Now that x goes from the center of the cone to a piece on the base edge of the cone, so that is the radius. So we're going to use volume, because we're talking about volume here, equals 1/3 pi r squared is the area of the base times the height. So 1/3 area of the base times the height. We have 1/3 times pi times the radius, which is x, squared times the height, which is 15. Made a little mistake here. I forgot to put in for the volume that it's 2,262. So, which way would I approach this? Now, there's more than one way to approach this, so whichever way you want works. First thing I would do is just focus on the fact that the 1/3 and the 15 are on the same side of the equal sign. If they are, you can multiply them together. And 1/3 times 15 is 1/3 of 15, which is just 5. So we have 5 pi. Actually, I'm going to get rid of the parentheses. I just had the hiccups a little bit. So we have x squared. So 2,262 equals 5 pi times x squared. And so now we want to get x by itself. So we're going to divide both sides by 5. I would do this in 2 separate steps just to make sure I don't make a mistake. So let me clear this, move this over. So we have 2,262 divided by 5. So we have 452.4 equals pi times x squared. Now I want to get rid of the pi. So I'm going to multiply both sides, or divide both sides by pi. So I take my calculator here and divide by pi. Enter. And so what I get then, let me scroll down. If you saw that, it was approximately 144. Really, if you rounded to 2 decimal places, it would still be 0.4. It would be 0.00 equals x squared. And then from there, what we want to do is square root both sides. So x is approximately, and most of you probably know the square root of 144, but we'll just do it on our calculator here to show that it's really close, if not almost exactly 12. And we don't have to put a unit on here because I believe they had feet with the x. They did. Right up there at the top left there, they had feet with the x, so we're just finding what x is. Last thing I'm going to do, just for the notes purpose, especially since I'm not here, is just scroll this calculator work and put it on this page so you can see all that. Go full page here for a second. Let's take this off, hide it a little bit. And so that's how you get that answer. So the x is approximately 12. It's still not exactly 12 from the information given because they said the volume was exactly 2,262 feet, but still pretty close. Now that's example 3, and really is the 4th problem we did because example 2 had 2 parts to it. The last problem we're going to do for example here is going to be called example 5 because I'm skipping example 4 in your textbook. And if you look, if you ever follow along with the reading, every example I do in class is like a different example with pretty much the same pictures sometimes, but different numbers in your textbook. So if you'd like to, you can look at example 4 in your textbook if you want the example 4 like the one I would have done, but I'm skipping it for numerous reasons, and we're just going to move on to example 5, which is kind of a fun problem. So let's get to that. Example 5 is about coolant being poured in through the funnel into a radiator, and it's being poured at a rate of 198 milliliters per second, and then it flows out of the funnel at a rate of 60 milliliters per second. So we're supposed to estimate how long it takes for the funnel to overflow. So what we're going to do is, first off, we're just kind of ignore the fact that there's a little tip on the funnel. We're going to take this as a whole shape and just call it a cone. So it looks like a cone here. We're going to take it as a cone. So the volume will be 1/3 pi r squared h. That is the volume of a cone. So we're going to use that to find the volume. So what we get then is 1/3 times pi. We'll use 3.14, or the pi in our calculator as an approximation, times the radius, which if you look here, the radius is from the center of the circle to a point on it, so that's 8 centimeters, times the height, which is up and down here, 9 centimeters. We could type all this in our calculator. It might be good to know that 1/3 of 9 is 3, 3 times 8 is 24, so really the answer is 24 pi, but again, we don't want just 24 pi, so I'll show you that it's going to be the same thing. But really, we have 1/3 times pi times 8 times 9. And so I just did some simplifying that you really don't have to do because your calculator can handle all of it. But all I did was take 1/3 of 9, which is 3, and 3 times 8 is 24, and we solved the pi there. So either way you do it, the volume of this funnel is approximately 75.3, actually let's round that up, 75 erase that. 75.4 cubic centimeters. That's the volume of the funnel. Now what we want to do is figure out how fast it overflows. So let's talk about how coolant is being poured into this funnel. Coolant's being poured into the funnel at a rate of 198 milliliters per second. Okay, I need to move my work here, I think. Oh, all right. I'll just leave it. Let's draw a line. Well, that coolant is coming out of the funnel. Not as fast, but it's coming out at a rate of 60 milliliters per second. So I called this fill-up rate. How fast is the funnel filling up? Well, if you're pouring it in at 198 milliliters per second and it's only coming out at 60 milliliters per second, all you'd have to do is subtract those. And subtracting 60 from 198 will get you 138 milliliters per second. So that's how fast it's filling up. Now back to our volume answer here. Our answer for volume was 75.4 cubic centimeters. Now a problem that might occur here, we might notice, is the fact that our fill-up rate has milliliters in seconds and our volume of the funnel is in cubic centimeters. So what we need to do is get that in the same unit. Now when you're dealing with volume of a solid, like we've been doing in class, your units are going to be some distance measure cubed. For example, in this problem, our distance measure cubed is centimeters cubed. So that's the volume of a solid. But when you're dealing with volume of a liquid, you're either going to use gallons maybe, or in a lot of cases, like here, liters or milliliters. So we're using milliliters for a liquid volume. So we need to convert the two. Now in the back of your textbook, I believe, yeah, there is a conversion. And in the back there, they give you a lot of different conversions between things. But the best one in there is the fact that 1 liter is 1,000 milliliters or 1,000 cubic centimeters. When you look at that, you might realize that 1,000 milliliters is the same as 1,000 cubic centimeters. So if you did not know this, and this is something I remember from my science class in high school, but if we have 75.4 cubic centimeters, there's going to be 75.4 milliliters. That would be the liquid volume. So a cubic centimeter is the same as 1 milliliter. So now what we need to do is multiply or divide or something to get this into how long it takes. So let's think about this for a second. Look at our units. Well, we're going to take 138. I'm blanking on this for a second, so just give me a second to think it through. Yeah, that's what I thought. Okay. I think I did something wrong here. Oh my goodness. I hate when I make mistakes. I do this and I record it. So I'm going to go back. I made a mistake and I was wondering why this number, something wasn't working out. So I do apologize, but I forgot to square the 8 right there. There it should have been squared. So I just put that. Now it doesn't even look like I'm trying to square something. So let me erase that. So here's my mistake. I forgot to square the 8. So going back and fixing this all would be wrong. So I'll take out the calculator. Probably still has the same work in there. All I have to do is really go and let's clear this actually. Clear. Second, enter, but go back. And this should have been not 8, but 8 squared. Second, insert a square symbol. This is going to make a lot more sense. So now actually, you know what I'm going to do? Instead of crossing it out, I'm just going to delete this all. Because you make mistakes, you can fix them. And then I'm going to take this, delete this. And then I'm going to take the new calculations. So if you check the notes online, you might not even notice that I made a mistake when I recorded this. but since you're in class listening to it, you might notice. So what we really have is 603.19 milliliters. A little bit better measurement for the funnel. And that's what we get. All right, back to the last part of this problem. It's a little confusing. That's why I was looking at the numbers, just getting mixed up. But here's what we're going to do is we need to get our answer in time. So what we're going to do is we're going to take the 603.19 milliliters and we're going to divide by how long it takes, which is 138 milliliters per second. Now when you divide, one thing you can do, as you should have learned probably in a previous math course, is you can multiply by the reciprocal, which is 1 over 138. And what happens here is instead of milliliters over seconds, it becomes seconds over milliliters. And what happens with the milliliters is they cancel out. And so what you'll get for a unit is just seconds. And so then I'll take here my calculator, take the answer we just got, so I'm going to clear it, second answer, and I'm going to multiply by the reciprocal, which is 1 divided by 138. So I'll put that work over there from the calculator, and as you can see, I got 4.37 seconds approximately. So let me go full screen so you can see everything, with now the mistake fixed, the fact that I forgot to square the 8. So you've got your funnel in your radiator there, and you're pouring your coolant in at a rate of 198 milliliters per second. It's coming out at 60 milliliters per second. You start now, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. It's on the ground. You got to pull up if you were pouring that slow. Normally you slow up and adjust it, of course. But so that's the lesson, as in what you need to know, what things I was going to go over here with you guys. So now all we're ready left to do is to give you your homework. And this homework, if you look at it, is page 755 to 757, 11, 12, 14, 17 through 25, the odds. A lot of odd problems. Now with this homework, I'm well aware, as you're probably well aware, that the answers are in the back for odds. So what I want you to do is I want you to try these problems, and then before you come to class, I want you to check your answers. Obviously, you can't do it on 12 and 14. Now, I'll know if you just copy them down because all these problems involve some work. So you need to show your work, do the problems, and if you don't understand how to get the right answer, you got to make sure you're asked tomorrow in class, because he'll have time to go over this, but not a whole lot of time, because you'll probably have to go over some of the homework that was due for today. So that's your homework assignment. And looking at the recording time here, there's about 15, 16 minutes left in class if you started right at the bell, which I'm sure there was some delay. So you'll have that time now to work on this homework, and that's what you should be doing, working on this homework. And then you'll have not much to do tonight if you get this homework done now. So that is it, and I'm going to stop this right now, and I hope you have a wonderful Tuesday.